This is our presentation on the environmental impacts of mountaintop mining on central Appalachian aquatic ecosystems.
MTVF is a mining process that consists of removing the top of mountain summits. You can do this by using dynamite or heavy machinery. The problem arises when the minerals are exposed to air and they create sulfuric acid and iron hydroxides. These are acidic, and this can cause drainage problems. Uh, However, there are processes to regulate these. They're regulated by federal laws such as Surface Mining Control and Reclamation Act and also the Clean Water Act. And these are regulated by government bodies such as the EPA and the Army Corps of Engineers. The effects of MTVF. The runoff from the mining affects the water flow and also the water toxicity. The invertebrates that are affected are the mayflies, and then the main vertebrates that are affected are the salamanders. And then the stream obviously is affected. You have the headwater and also the loss of soil. These are mainly affected because the runoff changes the concentration of ions in the water and also just contains general pollutants.
Next up, we have the local environmental impacts of mountaintop removal and MTF. The first one is water pollution. There's minerals inside that we're blowing up and they're being exposed to air and water. This is creating toxic chemicals and this is really bad for the aquatic life. Then we have stream habitat loss. We're basically just putting a bunch of metals and this is destroying the habitat for the wildlife. And then we are basically removing the forest, we're clearing it out, and this is leading to habitat destruction and loss of biodiversity. Then we have soil erosion, we're just removing vegetation. This is just increasing the erosion, making the land unstable. And then as for us, there's a bunch of health risks that are associated with air and can lead to health problems for nearby communities. Next up, I pulled this image from the article that we read, and this is basically showing that iron is participating in the streams near mountaintop mining. This is in Kentucky, so as we see on the left here, the mining operations causes iron to oxidize and settle on the stream beds. This is basically coating them. This is the reddish-brown iron deposits covering the bottom, alternating the natural state. Basically, iron builds up, lowers oxygen levels, affecting the aquatic life, and then this is basically harming the fish, plants, and reduces overall biodiversity.
There are many impacts on the environment when it comes to coal mining, but one of the far-reaching environmental impacts of mountaintop removal and MTVF is that the removal of vegetation, flattening of valleys, and the compaction of soil on mine sites alters the patterns of water flow. And this is very bad for the environment. When the water source is gone, many vegetation and other wildlife are diminished. As you can see on the bottom image, on the left side, there are trees and other plantation because they have a water source. But when that source is gone, the aftermath, it's dry, lifeless land, as you can see on the right side of that image. Mitigation for MTVF generally includes efforts from their side to create streams on the mining site that have been destroyed and sometimes also restore streams in nearby watersheds. The SMCRA regulation is there to make sure that the watersheds that have been impacted by MTVF to be returned to their former shape. Although these are some rules put in to help the streams, there are limitations to these mitigations. Mountaintop mining have not used these available methods for measuring ecological functions. These must be measured to determine how and whether they may be brought back to the right level. This is a problem because if they don't put the streams back in the right direction or the right amount of water is put back in the stream, it can have major effects on the environment.
Mountaintop removal affects mountains in two main ways: effects on local scales through lost streams, lost soils, and altered hydrology, and longitudinal impacts through elevated conductivity, co-occurring containments, and sulfates. Lost soils happen through erosion and oxidation by soil microbes that results in a loss of significant amount of soil. The soil horizons that are formed over previous centuries will be dramatically changed by homogenizing the remaining soil to combine organic and mineral soils. Lost streams are a section of drainage streams turned into a sediment pond by MTVF mines to collect waste and sediments produced during the mining process. The sediment pond is situated at the foot of a recently created mine. The water passes over through blasted rock, thickening through the valley fill and into settling ponds before entering the stream network, ultimately polluting the surrounding area. And co-occurring containments is categorized as electrical conductivity and total suspended particles in receiving streams, which rise sharply because of the release of co-occurring contaminants, ultimately polluting the area, and sulfates, which have a concentration increase tenfold or more in freshwater systems across North America because of the regional sulfate emissions. Sulfate concentrations in West Virginia affected streams are frequently 30 to 40 times greater than those of seawater due to mining activities.
Restoration is an integral part of restoring the environment back to its normal state before the mining started. One of the ways to restore the channels is to make the old mine drains into channels or build new ones to mimic the streams that were present in the landscape before the mining started, so that the environment can flourish. But just building some channels is not going to help the environment also. They need to have the capacity to transport nutrients and biomass and irrigate the areas as well. The current regulatory framework is not good for the environment. They give more importance to the structure of the channel than to the ecological function of the stream. The next important step is to implement actual standards that have been peer-reviewed to have shown good results. The results should show how well the environment is performing in the current situation. The regulation need to be stricter as companies find loopholes in the regulation and proceed to do the opposite of restoration or creation of channels. Companies, instead of restoring the channels, do some minor beautifications to the channels and say that they have been restored or created new channels. The NCD regulation is completely bad set of regulations to follow, as they give importance to the structure of the channel instead of the function of the channel. And that concludes our presentation. Thank you very much.